Hello everyone, welcome back to my channel Shraddha's Physics. In our previous 5 lectures, we have discussed some part of the complex analysis. So, today we will see some problems based on the complex numbers. These problems will be based on the previous concepts. So, let us take the first example, find the additive inverse and multiplicative inverse of z equal to 3 minus 4i. So, z equal to 3 minus 4i. So, to calculate first the additive inverse means we have to calculate minus z. So, minus z will be equal to minus of 3 minus 4i. This will be equal to minus 3 plus 4i, clear. Similarly, for the multiplicative inverse we have to calculate z is given 3 minus 4i and we have to calculate 1 by z. So, 1 by z will be equal to 1 by 3 minus 4i. Since in the denominator it is 3 minus 4i, we have to multiply the complex conjugate of 3 minus 4i, that will be 3 plus 4i in the denominator as well as the numerator. So, this will be 3 plus 4i divided by 3 plus 4i. So, that the denominator becomes the real number, that will be equal to, this will be in the numerator, this is 3 plus 4i divided by a minus b into a plus b form. So, this will be equal to 3 square plus 4 square, because I square you know minus 1. So, minus minus becomes plus, 3 square plus 4 square. So, that will be equal to 3 plus 4i divided by 3 square is 9 and 4 square is 16, that will be 25. 9 plus 16 is 25. Hence, separating the real term and the imaginary term, we will get this will be 3 by 25 and plus iota 4 by 25, clear. This is 4 by 25. The basic difference between the additive inverse and multiplicative inverse is, when you are been asked to calculate the additive inverse, this is simply minus of z, and for the multiplicative inverse you have to calculate 1 by z, because you know z plus minus of z, when you add the additive inverse with that number, then that will become 0, because 0 is known as the additive identity. And similarly, when we will multiply z with the multiplicative inverse, that is 1 by z, then this will becomes 1, because 1 is the multiplicative identity, clear. Let us take another example. Let us calculate 1 plus I divided by 1 minus I. So, to calculate 1 plus I divided by 1 minus I, then since it is 1 minus I in the denominator, we have to multiply its conjugate, that is 1 plus I in the denominator as well as numerator. So, this will becomes 1 plus I whole square in the numerator divided by 1 minus I into 1 plus I, clear. That will be equal to 1 plus I whole square, means this is in the form of a plus b whole square. So, I can write this will be 1 plus 2i minus 1, because I square is 1, I square is minus 1, divided by, this is in the form of a minus b into a plus b, 1 minus I into 1 plus I. So, this will becomes 1 plus 1, because I square is minus 1, this will becomes 1 get cancelled, 2i divided by 2. So, that will be equal to simply iota, clear. Now, calculate the modulus of 1 plus I divided by 1 minus I. So, 1 plus I divided by 1 minus I modulus. So, if you can remember the formula, that is z1 divided by z2 whole modulus, we can write z1 modulus divided by z2 modulus. So, I can write here, this is the modulus of 1 plus I divided by the modulus of 1 minus I, clear. Now, we can write modulus of 1 plus I is, as we can write mod z equal to z into z star root over. Similarly, here we can write 1 plus I modulus equal to 1 plus I into, this is 1 plus I into 1 minus I, its conjugate in the place of conjugate we have to simply put minus in the part of the imaginary and again this root over divided by, in the denominator we have to write this is again 1 minus I and its conjugate will be 1 plus iota and again the whole root over. Clear? Now you can see the denominator and numerator is same, or you may calculate this 1 plus I into 1 minus I. It is in the form of a plus b into a minus b, that is again 1 plus 1, that is 2. So this will be root over 2 and divided by the same root over 2, or you can directly cancel because these are the same term. So the after cancelling we will get 1. So this is the difference between when we will calculate 1 plus I divided by 1 minus I, this will be I, and when we will calculate the modulus of 1 plus I divided by 1 minus I, then this will becomes 1. Let us see some more examples. Here it is been given what is the value of 1 plus I into 1 plus I whole 1 plus I cube into 1 plus I power 5 into 1 plus I power 7, so on up to the 2n factors. So let us see, this the first term is 1 plus iota and the second term is 1 plus I cube. So you know I square is minus 1. So I cube will be equal to I square into I. So I square into I means this will be minus I, because I square is minus 1. So minus 1 into I. So this will becomes minus I. So here I have to write 1 in place of I cube. I have to write this will be minus I. Clear? Similarly, in place of 1 plus I power 5, for I power 5 I have to write this as I square whole square into I can write like this. So this will be I square means minus 1 power 2 into iota, minus 1 square is plus 1 and this will be plus 1 into I. So this will becomes iota. So I can write here 1 plus iota in place of I power 5. Similarly, for 1 plus I power 7, I can write this as I power 5 into I square. I power 5 is I into I square means minus 1. So this will be again 1 minus iota. Clear? And this will continue, this term will continue up to, this will continue as 1 plus I into 1 minus I. Okay. Since it is given, you can see that this is 2n factor, then you can see let us take 1 plus I into 1 minus I. This is in the form of a plus b into a minus b. So the first term, this first two term, this will be like 1 plus I into 1 minus I. So this will be 1 square minus of I square. So this will be 1 plus 1, that will be 2. Similarly, for these two term, this will be into 2 and this process will continue up to this 1 plus I into 1 minus I. So this will be again 2. So this will becomes, you can see that here I am taking this 2 term as 1, that is 2, and again this 2 term as 2 and so on. So that these two terms, for these two terms, now I can write this as the total number there becomes, there will be n factors. Clear? Since here we are considering for these two terms as 2, again 1 plus I into 1 minus I as 2, so that we can write this will be 2 into 2 into 2 and so on up to the n factors. That will be equal to nothing but 2 raised power n. Clear? So this will be the answer, that is equal to 2 power n. Now take another example. It is given z equal to 1 plus iota root over 3. So you have to calculate the polar form of z. Polar form of z means in terms of r and theta. So you know, first of all, z equal to, in terms of polar form I can write z equal to r exponential I theta. So this is r exponential iota into theta. So you have to calculate r and theta. So r equal to, we have already discussed, that is x square plus y square, where x and y are the real numbers and it is in the Cartesian coordinate system, and also theta equal to tan inverse y by x, or this is the imaginary part of z divided by the real part of z. Okay. So, let us see z equal to here given 1 plus iota root over 3. If I will compare with z equal to x plus y, so now x will be equal to 1 and y will be equal to root over 3, clear. So, this will x equal to 1 and here if you will compare y equal to root over 3. Now, from this relation you can calculate r will be equal to root over of, in place of x you can write this will be 1 square plus y here is root over 3 square is 3, root 3 square is simply 3. So, this will be equal to 1 square is 1 plus 3, that will be 4, root over of 4 equal to, this is your 2. Or also you can calculate as, since z is given, you know mod z equal to r, so that you can also calculate this as 1 plus iota root 3 into its conjugate, that is 1 minus iota root 3. So, by multiplying this you can also calculate 1 plus iota root 3 into 1 minus iota root 3 whole root over. So, by calculating this you can also calculate the radius or your r. So, this is equal to 2, this or this you may calculate in this process or in this process. So, here you have calculated r. Now, theta will be equal to tan inverse y by x. So, y is here root over 3 divided by x is 1. So, this is equal to tan inverse root over 3. So, the value of tan inverse root over 3 is nothing but how much? Will be pi by 3. So, theta will be equal to pi by 3, clear. Now, we have calculated r value, that is 2 and theta value is pi by 3. We have to just put the value of r and theta in this equation, that is z equal to r exponential iota theta. Hence, it will be equal to z equal to r is 2 exponential iota, in place of theta I have to put this is pi by 3. So, this is the polar representation of the z, that is 1 plus iota root 3, that is equal to z equal to 2 exponential iota pi by 3 sorry. Or also you can write it as pi by 3 plus 2k pi, or also you can write this as z equal to you can write 2 exponential I pi by 3 plus 2k pi, okay. Now, for this you have to calculate argument of z, small argument of z and capital argument of z. You have to calculate argument of z. Argument of z, you know the argument of z equal to, we can write this as theta plus 2k pi. So, from the previous relation, that is in the polar form, we have calculated this z equal to r exponential I theta, that is equal to r value is 2 and this will be exponential iota, theta value is pi by 3 and also we can add 2k pi, because for this rotation 2k pi rotation this value remains same with the value of k equal to 0, 1, 2 and so on. The value of k is 0, 1, 2 and so on. So, now this value pi by 3 plus 2k pi, it is nothing but the argument of z, that is the small argument of z is pi by 3 plus 2k pi, clear. This is the argument of z, small argument of z. Now, for the capital argument of z, this is known as the principal argument. This is the original part, or you can say this is the single valued function, that is it has the only value, that is pi by 3. Okay, this pi by 3, this original value or the first value that we have calculated, this is the pi by 3 and we can say that this is the single valued function. Argument of z, capital argument z is the single valued function, so that it has the only one value, that is pi by 3, and this small argument of z, it has many values, that is plus 2k pi means here you can put the value of k equal to 0, 1, 2 and so on. So, it is a multi-valued function, we have already discussed it, okay, and its unit is radian, okay. You have to write this as argument of z equal to pi by 3 radian. So, this is all for today. If you like the video, you can give a like, share and subscribe to my channel. Thank you.